Hello brother and sisters. In this video, I am going to discuss about classical mechanics and especially about the Lagrangian and Hamiltonian topic. One question in GATE and one question in CSIR net definitely comes from these topics, that is Lagrangian and Hamiltonian. Lagrangian and Hamiltonian. From these two topics, definitely one question is going to come in the exam. So in this video, we are going to discuss about this. Okay, let's start it without wasting much time. Rigid body. If shape and size are relevant to discuss motion of a particle, then a body can be treated as a rigid body. See, to discuss suppose this is a particle, and to discuss the motion of this particle, if its shape and size is mattering to us, then that body can be treated as a rigid body. And if any body is there whose shape and size do not matter, whatever the motion of the object it is, so then that body can be treated as a point particle. So this is written, if the shape and size are relevant to discuss motion of a particle, then a body can be treated as a rigid body. If shape and size are not relevant, then body is point particle. So to discuss the motion of a particle, if shape and size are relevant, means they are coming into picture while discussing the motion of an object, that means that is a rigid body. And if any body is there or any object is there, and whenever we are discussing its motion, their shape and size are not mattering or not any having relevant, so that particle can be treated as a point particle. State of a classical system. Function belonging to position and its conjugate momentum at a particular point of time is px m dx upon dt. Actually, it is momentum. P is equal to product of mass and velocity. And what we can write velocity? We can write velocity change in distance per unit time. So that's why we have written Px is equal to m dx upon dt. Now what they are saying, that if we need to define the state of any classical system. So to define the state of any classical system, that means that should be a function belonging to position and its conjugate momentum. To define a classical state at any particular time, we need to define it in the terms of position and momentum. So why we are calling here conjugate momentum? Means conjugate momentum means Px is equal to m dx upon dt. Means if the momentum is in x direction, then the velocity or change in distance should also be in a x direction. If momentum is defined in y direction, then change in distance should also be in y direction with respect to time. So this is conjugate momentum. Pz m dz upon dt. If we are defining a momentum in a z direction, then the change in distance should be in a z direction only. So this is a conjugate momentum. So what is the state of classical system? Function belonging to position and its conjugate momentum at a particular point of time is For example, px m dx upon dt, py m dy upon dt, pz m dz upon dt. Next comes the equation of motion. Equation of motion in Newton's law, which is actually a relation between A means acceleration, V means velocity, and x means distance at a particular time. So what is the equation of motion, which is based on Newton's law and which is having a relation between acceleration, velocity and distance at a particular time that is equation of motion. So now let's study what is coordinate system. See, for example, if we need to define the position of the particle, or we need to know what is the position of particle in a 3 dimensions. So we can define it with a position, for example, r xi cap plus yj cap plus zk cap. Suppose a particle is at this point, which is in 3-dimensional space. So in 3-dimensional space, 3 directions are included, and those directions are I cap, j cap and k cap. And x, y, z are the point of x-axis, y-axis and z-axis. Now this is the position of the particle. If suppose that particle start moving, if the particles start moving, that means that will have some velocity. So we put r dot. R dot means velocity of a particle, means dr upon dt, change in distance per unit time. So r dot will be equal to x dot I cap plus y dot j cap plus z dot k cap. Next come T. T means kinetic energy, that is half PV. How it is? Half P dot V. See, we know that kinetic energy is half mv square, and we also know that we can write this mv dot V. So what is mv? P. Half P dot V. This is what? Kinetic energy. Now suppose if we differentiate this kinetic energy with respect to time, so it will become half. First of all, what we will do, we are going to differentiate it with momentum, that is dp upon dt, keeping velocity as constant, and then keeping momentum as constant, we are going to differentiate with velocity. Change in distance per unit, change in kinetic energy per unit time. We can also write it half m r dot r dot. Why? Because we know that half m v square and half m v dot v, which is equivalent to half m r dot r dot, means r dot square. T is equal to half m. What is r dot square? What is r dot? That is x dot square plus y dot square plus z dot square. So this is the kinetic energy in a coordinate system. So next systems comes our cylindrical coordinate system. See, in cylindrical coordinate system, r is measured from z-axis. The measurement of r is done from the z-axis. Okay, x is over here r cos theta, y is r sine theta, and z is height over here. Now next comes the dynamic variable. What is dynamic variable? Change with time. The variable which are changing with time. It can be of two types, that is implicit or explicit with time. See, for example, if any of the function is there and if we are going to differentiate with respect to time, if it is going to give 0, then it is implicit time. If a function is given to us and if we are going to differentiate it, and if it is not coming equal to 0, then it is of explicit type. X dot can be, see, x is equal to r cos theta. If we are going to differentiate it, it will become r dot cos theta plus r minus sin theta, theta dot. Similarly, y dot will become r dot sin theta plus r cos theta, theta dot. Z dot is equal to z dot only. Because z is a height. Z is not written in any of the form. Like x is written r cos theta, y is written r sin theta, and r is measured from z axis. Wherever the z axis is there, it is measured from there. For example, this is xy axis, this is y axis, and this is z axis. R is measured from z axis. Okay, the most important thing is the kinetic energy. What will be the kinetic energy in a cylindrical coordinate system? That will be half mr dot square, r square theta dot square, z dot square. See, it will be difficult for us to remember. So what we can do it is, see the coordinates in a cylindrical are r, theta, z. So, kinetic energy can be written as half m. First of all, this we will write this r dot square plus theta dot square plus z dot square. Then along with theta dot square we will write r square. So it will become easy for us to remember. See, let me remind you again how we can learn it. See, t is equal to half m. We will write these coordinate r dot square, theta dot square plus z dot square, and along with theta dot square we will put r square. So it will become a kinetic energy in a cylindrical coordinate system. Now next comes the spherical coordinate system. See in CSIR net exam or in GATE exam, we don't need to go in detail. What we need to know is whatever is the important. Whatever is important, just learn that on tips. That will be more important because we don't have to do PhD in a particular topic. What we need is the important thing, just do it properly. So in a spherical coordinate system, r sin theta is a projection of r in a xy plane. Just remember this thing only, that in a spherical coordinate system there will be a radius, and along with it there will be theta, which will have r sin theta, and see this is a sphere and this is the radius and this is the theta, and we know that r sin theta is a projection of r in a xy plane, and the projection which is made, this is the projection which is made, and the x-axis, between them one angle is made, that angle is phi. Again listen, there is a sphere which is having radius r, okay, and radius is there, and the angle between the z-axis and radius is denoted with theta. Now which will be divided into two components, r sin theta and r cos theta, and r sin theta is a projection of r in xy plane. If we have the projection of r in xy plane, that will be r sin theta. So this is what a projection is there. Now the angle between projection and x-axis is denoted with a phi. So what is x is? X is r sin theta cos phi, y is r sin theta sin phi, z is r cos theta, and t is equal to half mr dot square plus r square theta dot square plus r square sin square theta phi dot square. See how we are going to learn this? Let's say this. Half, see, in spherical coordinate r, theta and phi are the main coordinate. We will write half m r dot square plus theta dot square plus phi dot square. Okay. So we have written all these three coordinates in a dot form or in its form of velocity. So next, after that, leave this r dot square. This does not require any assistance. Theta dot square is there, so it will have r square along with it. Now next is phi dot square. So it will have an assistance of r square, and it will have the assistance of r and theta. So we will write here r square sin square theta phi dot square. See, first of all write r dot square, theta dot square, phi dot square. So r do not require anything. Then theta dot square will require what? It will require r. So we write r square. Next, phi will require r and theta both. That's why we have written r square sin square theta phi dot square. So this is the kinetic energy in a spherical polar coordinate. See, why we are learning all these in cylindrical? See, we need to remember this. Kinetic energy in cylindrical form and kinetic energy in spherical polar coordinate system, because this we will require while writing the Lagrangian of a system. Equation at constraint. The relationship between dynamic variable just now I have told, the variable which are changing with the time, is identified as equation of constraint. See, the relation between, if there are many dynamic variable, and the relation between those dynamic variable is identified as equation of constraint. See, there are two type of constraint. What is constraint? Constraint means that is blockage. which is stopping something to do something. You can understand constraint as a blockage. Okay, in Hindi you can say rukavat, which do not allow an object to do a particular motion, that is constraint. To put some restrictions, if any object is there and if we are putting restriction on it, that is a constraint. So what is constraint? To put some, which is a restriction, a type of restriction. So it is of two types. First is holonomic constraint. Constraint can be represented in the form of equation. Particle moving in xy plane, z is equal to 0. See, this is a holonomic constraint. See, they are saying a particle is there, which is, this is y-axis and this is x-axis. This is y and this is x-axis. If a particle is moving in an xy plane, okay, so the particle is allowed in xy plane. In which direction it is not allowed? It is not allowed in a z direction. So that's why we write here z is equal to 0. So z is equal to 0 is a holonomic constraint. Means this is a restriction. A particle is restricted to go in a z axis or in a z direction, because the motion of a particle is only defined in xy plane, not in xyz plane. So particle could not go in a z axis or z direction. So z is equal to 0 is a constraint, one type of a restriction. So such type of z is equal to 0, such type of constraint is known as holonomic constraint. They are exactly equal. Means in this there is no inequality. Next comes the non-holonomic constraint. When constraints are represented in terms of inequalities. Say if restrictions are there and those are in terms of inequalities. For example, one function q1, q2, q3. If a function is there which is represented in the terms of q1, q2, q3, then that should be equal to greater than or equal to 0. Means that is not equal to 0. So such type of constraint are non-holonomic constraint. Non-holonomic constraint can be derived from relationship between velocity. See, if there is a rolling without slipping, if something is rolling and there is no slipping in that, then v is equal to r omega. We can write v dx upon dt, means change in distance per unit time, and omega is what? Angular velocity. So change in angle per unit time will give you omega. So d theta upon dt into r. So if we are going to cut this dt over from both sides, then dx is equal to r d theta. Next come the very important part, degree of freedom, number of independent motion. What can be the independent motion of the particle? That is known as degree of freedom. The formula of degree of freedom is 3n minus k. K is number of holonomic constraint, means which are having equality, and n is number of particles. How many number of particles are there? That is 3n minus k is defined degree of freedom. Okay, generalized coordinate and generalized velocity. Let us look at this point. Any dynamic variable can be treated as generalized coordinate if it will explain independent motion of a system uniquely. Any of the dynamic variable is there. Any dynamic variable can be treated as generalized coordinate only if it explain independent motion of a system. कोई भी डायनेमिक वेरिएबल है उसको जनरलाइज कोऑर्डिनेट तभी बोलेंगे जब वो किसी भी सिस्टम का मोशन जो है इंडिपेंडेंटली डिफाइन कर देगा, जो किसी पे डिपेंड नहीं होगा। कोई भी ऐसा वेरिएबल जो किसी भी सिस्टम को क्या कर देगा, उसके मोशन को इंडिपेंडेंटली डिफाइन कर देगा। नेक्स्ट इज, it is not necessary that generalized coordinate have same dimensions and only dimension of length. This is not necessary that coordinate have same dimension and only dimension of length. Means ये बिल्कुल जरूरी नहीं है कि जनरलाइज्ड कोऑर्डिनेट्स जो है उनके सेम डायमेंशंस होंगे या फिर उनका जो डायमेंशन होगा लेंथ ही होगा। One of the important condition for generalized coordinate is that come in exam is the number of generalized coordinate must be equal to number of freedom. If any system is there and if we can call that system as an independent if the number of generalized coordinate are equal to the number of degree of freedom. Means generalized coordinate should be equal to number of degree of freedom. This is very important point, need to remember. If qi is generalized coordinate, then generalized velocity conjugate to qi is identified as qi dot. They are saying if qi is coordinate, okay, then its velocity, its conjugate velocity will be qi dot is equal to dqi by dt. Change in qi यानी position per unit time. If generalized coordinate and dimension are known, then q dot dp by dt is equal to f is generalized velocity. If generalized coordinate and dimensions are known to us, we are knowing them, then the position of particle is generalized velocity, or you can say that generalized velocity is equal to force. And they are saying it is not necessary that generalized velocity have same direction. So what we need to remember is, we need to remember how we can find out the degree of freedom, and the formula for degree of freedom is 3n minus k. Okay, come to the next question. Two particles constrained to move in a xy plane such that their distance is fixed and both are moving on a given curve, find the degree of freedom. So what is given to us in this question? See, whenever you do any question, first of all see only one thing, what is given in the, what we need to find out in a question. If we know what we need to find out in a question, then we can process it very easily. So what we need to find out in this question is degree of freedom. Next what we will do, see, we need to find out degree of freedom, and the formula of degree of freedom is 3n minus k. What is n? Number of particles, and What is K? Constraint. See, we need to find out degree of freedom, that is equal to 3n minus k. So, now we will see what is given in the question. Now, what is given in the question? Given to us is number of particles. What is? 2 particles are there. Means 3 into 2 minus k. 6 minus k. Okay. Move in a xy plane. They are moving in a xy plane. That is what is given to us. Constraint is given to us. How? Let's see. See, 2 particles are there. So both the particle 1, particle 2. This will have x1, y1, z1, x2, y2, z2. See, it is already defined in a question that it is given in a xy plane. Means the particle could not go in a z direction. So, the constraint is z1 is equal to 0, z2 equal to 0. So, this is what? One type of a constraint. So, these are the two constraints. Okay. Next constraint is that suppose this is a xy plane, 2 particles are there. Okay. And what more is given to us? Look in the question. 2 particles move in xy plane. From this much information, what we have find out? See, first of all in a question we need to find out what is question, what is asked. So degree of freedom is asked. Then what we will do? We will write formula of it. After writing formula, what we see? That we need to find out constraint also. So for taking out constraint, we will see the question what information is given to us. See, first of all they have given move in a xy plane, means z1 equal to 0, z2 is equal to 0. So these are the two constraints such that their distance is fixed and both are moving on a given curve. They are saying that their distance is fixed. Fixed means this much, this distance is fixed. So a particle is constrained between these points, that is length L, and that is defined as x2 minus x1 whole square plus y2 minus y1 whole square root over. So this is what? Third constraint. Now what is fourth constraint? See, this is first constraint, second constraint, this is third constraint, and this is fourth. y2 is equal to f1 x2. That means the particle which is in y2 direction cannot go in a x2 direction. And fifth constraint is y1 is equal to f2 x1. Means y1, particle, position of particle in y1 is equal to function of particle in x1. Means a particular particle which is in y2 cannot go in a x1, function of x1. So this is 5 constraint. Total constraint 5. Degree of freedom 2. So we will apply a formula 3n minus k. N is number of particle. 3 2 ja 6. Constraint 5. 6 minus 5 will give you 1. Come to the next question. A particle is constrained to move in an inner surface core with a half angle alpha as shown in the figure. See, this is the figure and a particle is constrained to move in this figure which is having an alpha angle. Write down the equation of constraint in Cartesian coordinate. See, we will need to find out the equation of constraint. See, where this particle is restricted. This particle is restricted in this particular angle. This much angle this particle is constrained. So what can be the equation of constraint in a cylindrical coordinate system? That will be equal to tan alpha, that is perpendicular upon base. Perpendicular can be written as root over x square plus y square and base is z. This is a particle, okay, and this is angle alpha. So perpendicular upon base is there, okay. So perpendicular is root over x square plus y square and base is z. It is like this, x, y, z. So base is z. So tan alpha is equal to, this is in a cylindrical coordinate, root over x square plus y square. While in a spherical coordinate, it will become r upon z. And in Cartesian coordinate, tan alpha will become equivalent to tan theta. Overall, what is constraint? Only one constraint is there. Just we have written in all the three types of coordinate. In cylindrical we can write root over x square plus y square upon z, and in spherical we can write r upon z. In Cartesian, tan alpha is equal to tan theta, means alpha equal to theta. Now what is degree of freedom? 3n minus k. Number of particle is 1. K is only 1. Only one constraint is there. These are only written in different coordinate system. 3 1 are 3 minus 1, 2. So what is the degree of freedom? 2. Two particles are there. This is M1, this is M2, okay. In this we need to find out the degree of freedom. Now first of all write the coordinate of this M1. See, x1, y1, it is not moving in z direction, na? So we will write here 0. So z1 is equal to 0. This is one type of the constraint over here. Now look at the M2 particle. It is 0, 0 and z2. Means x2 equal to 0, y2 is equal to 0. So these three are the constraint. Okay. Constraint are those direction in which a particle motion is not allowed, in which a particle cannot move. See, this mass 1 is there, it cannot move in a z1 direction. This mass 2 is there which cannot move in x2 and y2 direction. Next is the motion of a particle is fixed between these. Means it is restricted along with this length. And if we will apply it formula, it can be written as, that is distance formula we apply, that we use in smaller classes, x2 minus x1 whole square. So applying that formula, it comes like this: x1 square plus y1 square plus z2 square is equal to L root over. Now do the squaring on both sides. It will become x1 square plus y1 square, and it will become L minus, bring this z2 over here, L minus z2 whole square. Now degree of freedom is 3n minus k. Number of particle 2 is there and constraint are there 4. 3 2 ja 6 minus 4 gives 2. So degree of freedom is 2. Three 2 ja 6 minus 4, it will give us 2. So what is degree of freedom? 2. Again read next question. Two particles m1 m2 are attached and a massless rod of length L, where particle m1 is constrained to move in a x direction. Means the particle can move only in x direction. That means y1 z1 is 0, and particle m2 is constrained to move in a xy plane. Same condition as above, and the particle 2 is there that can move in a xy plane. Find the degree of freedom. Same conditions are there. See, in first case y1 z1 0, and in second case z2 is equal to 0, and third is the length between both those particles, that is x2 minus x1 whole square plus y2 whole square will give you length. Because this one particle m1 can only move in a x direction 0 0, and this particle can only move in a x2 y2 0. Only in this direction it can move. So z1 z2 is equal to 0 and y1 equal to 0. So these are the three constraints. Third constraint is this fixed length, and this fixed length can be defined with distance formula, x2 minus x1 whole square plus y2 whole square root over length L. So what is the degree of freedom? 3n minus k, which will give 3 2 ja 6 minus 4 will give you 2. So what is this? Degree of freedom. Next is calculation of variation. Del I is equal to del integration f y dot and x, and if it is a function of dx is equal to 0, y dot is equal to dy by dx. Euler's Lagrangian equation. The formula of Euler's Lagrangian equation is this, that change in function with respect to velocity of y, and again we will do the differentiation with respect to x-axis, minus change in function with respect to y-axis will give you 0. We will study it further. Before that, come to the one more question. What is the shortest distance between 2 points in a plane? Suppose this is a plane, what can be the shortest distance? So suppose S is equal to integration of ds. What is S? Integration of ds. What we can write S as? Root over dx square plus dy square. So del S will be del 1 plus dy. If we are going to take out dx from this root, it will become 1 plus dy by dx whole square. And we can write dy by dx whole square as root over 1 plus y dot whole square. This is function. Now apply the Euler's Lagrangian equation, which is d upon dx df by dy dot minus df by dy. See, change in function with respect to y will become 0 automatically. Next, what is left? D by dx df by dy dot. When we do df by dy dot, we got this. See, if suppose the differentiation of any function is 0. For example, dA by dt is equal to what? 0. This is a function whose differentiation is 0. When any differentiation is 0? Differentiation is 0 only at one point, and that point is that this function should be constant. So differentiation of d by dx and this function can only be 0 if it is equivalent to what? Constant. So what we have taken? We have taken it equivalent to constant. After that we have done the squaring of it. After squaring of it, we got y dot 1 minus alpha square equal to alpha square, or y dot alpha square 1 minus alpha square raised to power 1 by 2. So y dot become m. Now what is y? If we need to find out y, what is y dot? So we can write it in a manner y is equal to mx plus c. So next comes the Hamiltonian principle. See, the one of the most important thing which we need to remember about an action of a particle is there. Suppose any action of particle is there, okay, t1 from t2 time is defined, L is function. If a function is in the form of position, velocity and time, that is Lagrangian, and we define it with L. If anything is there which is in a, if Lagrangian is a understand in this way, Lagrangian is a function of velocity, distance and time. So if an action is there from t1 to t2, L qi position, qi dot distance, velocity, t time will give you 0. So particle follow path for which action is maximum. Remember one thing, that a particle will follow a path for which the action is maximum, not minimum, maximum. So we will further study in a next class about Lagrangian. and after that we will study Hamiltonian. In this lecture we mostly covered about degree of freedom, and one question can come from degree of freedom also. Thank you. Please share and subscribe my channel. If you are having any difficulty, so please you can give comment, you can tell in a comment section what if you are finding any difficulty. Thank you. Have a nice day.